So if we do not know sigma, we're going to use our sample standard deviation, but we're also going to have to use a different distribution. So if you can see, this right here is the t distribution. It's still a normal distribution, right? But it's much less steep and precise compared to the z distribution. So we're going to have a much wider distribution. The standard deviation is slightly larger. So this is the formula that you would use to calculate the margin of error, but for the purpose of this class, we're not going to go too in depth with this. We're going to use Microsoft Excel. One thing that you want to know is degrees of freedom. These are critical values that are basis, or these are the basis of the critical value, is always n minus 1. So if you're asked to find the degrees of freedom, you're always going to just take a 1 away from the sample size. So this says we want to find the mean lengths of men's forearms, elbow to fingertip, with a 99% confidence. Here is our sample information. It tells us that our sample mean, or x bar, was 14.5 inches with a sample standard deviation of 0.7. And we measured 32 men's forearms. So 14.5 is our sample mean. Our sample standard deviation is 0.7. N is 32 because we measured 32 men's forearms, and we're going to use a confidence level of 0.99. So now we're going to go to our Excel spreadsheet. This time we do not know sigma. You notice sigma is unknown here. We just have our sample mean, which is 14.1, I think, 14.1, 14.5, sorry. Our confidence level is 0.99. Our standard deviation is 0.7, and our sample size was 32. And we get our, let's round this one decimal place, so 14.2 to 14.8. So it's from 14.2 to 14.8. So we're going to put 14.2 on the left-hand side. We're going to put 14.8 on the right-hand side. We're going to put our point estimate of 14.5 in the middle. And again, remember to calculate the margin of error. We just take the difference in these two values. So 14.8 minus 14.5, which is 0.3. So now our two statements, we are 99% confident that the mean lengths of men's forearms is between 14.2 and 14.8. Or another way we could say this, if we want to use the plus minus notation, we are 99% confident that the mean lengths of men's forearms is 14.5 inches with a margin of error of 0.3. Let's try another one of these. In a sample of 40 chocolate chip cookies, the mean number of chocolate chips was 22.7 and the standard deviation of 3.2. Construct a 95% confidence interval for the mean number of chocolate chips. So here our sample mean was 22.7. Our sample standard deviation was 3.2. The number of chocolate chips is 40, and we're going to use a confidence level of 0.95. So let's put those values into Excel. So I'm actually going to move this over so I can kind of see what I'm doing. So 22.7 was our sample mean, and 3.2 was our standard deviation. I think we sampled 40 cookies, and I'm going to have to take a look back. What was our confidence level? We want to be 95% confident. So we get an interval of 21.7 and 23.7. So it doesn't ask us to do that plus minus notation here, so we can say we are 95% confident that the mean number of chocolate chip cookies is between 21.7 and 23.7 chips. All right, the last one we're going to do here is let me scroll down a little bit. It says, what is the average pulse rate for statistics students on the first day of class? Our sample information will be the pulse rates of 15 randomly selected students at the beginning of the semester, and here are those pulse rates: 60, 68, 80, 80, 80, 86, 86, 86, 86, 86, 88, 90, 90, or 90, 102, 120, and 120. Now, what we need is we need that sample mean, the sample standard deviation, and the confidence level. Way, way, way back, we talked about this, and we could go all the way back and enter that into the one variable statistics spreadsheet, right? We could put that data in here and get our mean and standard deviation. But they've actually, I did you a favor, and we added this down here, so we can actually put that data in this Excel spreadsheet, and I kind of gave you a mini version of the one variable statistics spreadsheet that just gives you the mean and standard deviation. So we're going to type those numbers in below. So 60, 68, 80, 80, 80, 86, 86, 86, 86, 86, 88, 90, 102, 120, 120. All right, and I go take a look, and I'm going to make this larger now. And let me just remember, we wanted a 99% confidence level here, okay? So it tells me my sample mean is 87.87, so I'm going to put that in here. Again, we don't know the population standard deviation, so we're going to use S, not the left-hand side, because we don't know sigma. So it's going to be 87.87 with a confidence level of 0.99 and a standard deviation of 16.13, and our sample size was 15. Oops. So 75.5 to 100.3. So our 75.5 to 100.3 would be our interval. Now let's think about this. So I'm going to have 75.5 here. I'm going to have 100.3 here. My middle value is going to be my sample mean, or my point estimate, which was 87.87. So that's going to go right here in the middle. And then I just need to find that margin of error by taking the difference between 87.87 minus 100.3. Or I'm sorry, 100.3 minus 87.87, which is 12.43. So my margin of error is equal to 12.43. So we could say we are 99% confident that the mean pulse rates of all statistics students on the first day of class is between 75.5 and 100.3. Or we could say that we are 99% confident that the mean pulse rates of all statistics students on the first day of class is 87.87 within a margin of error of 12.43.